Hey guys, in this video we're going to look at how we go about writing electron subshell configurations. So looking at the key learning goals for this video, you should be able to, by the end of this video, use the electron subshell chart in order to determine the correct order in which the subshells are filled. We'll look at what those electron subshell charts are in a bit. And the second goal is that you should be able to write electron subshell configurations by writing those building blocks in correct order and filling them appropriately. So in order to do that, you need to be able to first interpret that electron subshell chart. So we're going to start there. We're going to start by looking at those electron subshell charts. So I've copied from the internet two different electron subshell charts. You'll probably see them represented in a number of different ways, but all of them should really tell you the same thing. They tell you in what order we should be filling the subshells. Now the order is based on the fact that electrons want to go into the lowest energy levels first. So let's just follow this diagram here on the left. This one is a bit easier to follow. The 1s subshell, the first subshell the electrons want to fill into, is the lowest energy subshell of all the subshells. And if we continue along this chart and we just follow this line, we then come to the next subshell, the 2s subshell, which is the next energy level, which doesn't have as low of an energy as 1s, but it is the next lowest one. So we just continue along. 2p is the next lowest energy level that'll be filled, 3s, so on and so on. So if you just follow this line, you gradually fill up those subshells. So there's an order, and the order we'll look at when we start writing. The order we will apply when we start writing electron subshell configurations later in this video. But before we do that, let's just look at this other diagram here. Now this is what I would argue would be a more typical diagram that doesn't have these these perforated lines that you see. If I just delete my scribbles, doesn't have these lines here that tell you to go to your next arrow, so these are the arrows here, and then there's like an arrow, there's like a perforated line in between. See, you don't have that in this diagram. So in this diagram here, you just have the arrows themselves. So you need to be able to read this kind of diagram, and I would argue that if you, because these diagrams aren't given on assessment tasks and exams, you should be able to produce one of your own, and more or less you will produce a diagram such as that one. So you need to be able to read this. Now you do the same thing, you follow the arrows, but when you get to the end of an arrow, you have to make your way up to the next arrow, and that's what this perforated line, these perforated lines over here are doing. They're guiding you to the next arrow. You have to be able to mentally do that yourself. You get to the end of an arrow, and then you go to the next one. When you get to the end of an arrow, you go to the tail of the next one. So you get to the end, or the head, and you go to the next one. And so you should be able to establish the order of the subshells in the same way. So the differences in the representations of these electron subshell energy diagrams here, I guess, if that's what we can call them. Maybe that's not such a good name, but these diagrams that tell us the order of the subshells in terms of how they should be filled. This one is definitely much, I would say, more effective, but it's also a little bit messier. There's just more stuff going on. This one is simpler, but you might run the risk of not knowing where to start or where to go. So always know that you start at the top and you follow the arrows, and when you get to the end, you could just go to the next arrow. You just keep going to each subsequent arrow when you get to the end of the other. So make sure you are able to read these electron subshell charts, as I've called them up here. these subshell charts, and this will tell you the order in which the subshells are filled. Now, the second goal is to be able to write electron subshell configurations, that is by using putting together those building blocks that we looked at in the last video. So building block examples are, 1s2, 5d, 7. These are all the building blocks. Putting these together in the correct order and filling them appropriately. So I'm going to give you one example, and then I'm going to give you three problems that I want you to solve on your own. The example I'm going to give you is phosphorus. Okay, so phosphorus. The first thing you need to do, as is when you work out the electron shell configurations, you need to work out how many electrons you need to distribute among the subshells. So in order to work out how many electrons you have, you need to work out the atomic number. So the atomic number of phosphorus is 15. So phosphorus with an atomic number of 15. So Z equals 15. So Z meaning atomic number. Phosphorus has 15 electrons. Now we need to distribute those 15 electrons. So if we follow the order of this chart here, the first subshell to be filled is the 1s subshell. Now, because the S subshell can only hold 2 electrons, we will put in those 2 that will completely fill it out. And we still have 13 more electrons to fill into the subshells to follow. So the next subshell, if we follow this diagram, we go to the next arrow because we reach the end of this arrow. We're going to go to the next one. The next subshell is the 2s subshell. So the 2s here, how many electrons can go into the S subshell? 2. And so we can put in 2, and we still have 11 electrons to go. So we're going to keep going along. We reach the end of this arrow, go to the next one. We reach 2p. Now 2p, a p subshell can hold 6 electrons. So we can fill it out completely because we still have more to go. And that is a total of 10 electrons, leaving us with 5 more to fill into the remaining subshells to follow. So we go on to 3s. S can only hold 2, so let's fill it out. We reach the end of the arrow on the chart. We go to the next one. The next subshell is 3p. Now, so we've got 12 electrons in total that have been filled into each of these initial subshells. Now that we have 12, we only have 3 left. So these 3 electrons will go into the final subshell, the 3p subshell. So this is the electron subshell configuration of phosphorus. Alright, now for some examples. I'm going to write them out. Once they're written, you should pause the video, try to write them out yourself, and then check them with the answer that is given at the end of the video. Okay, so we have zinc, we have argon, and then we have rutherfordium. So you need to find these elements in the periodic table and work out the number of electrons first. Alright, so I've completed the electron subshell configurations for the 3 elements, and I do want to apologize that I've given the wrong element for the 3rd one. I thought I'd given you, if you look at the periodic table, I thought I'd given you ruthenium. That was the one that was in mind, but somehow that became rutherfordium. Rutherfordium over here. Ruthenium, rutherfordium. So that was a massive electron subshell configuration. But if you follow the chart and you remember the principles that about the subshells, that the S has 2, P has 6, D has 10, F has 14, you just follow that chart. You will finish the subshell configuration, and this is what I got. Now I know that it will be a bit of a pain to read this, So it might help you by underlining each of those building blocks, okay? All right. Hopefully that wasn't too stressful. All right, guys. That is how we write electron subshell configurations.